Okay. This is the first part of the lecture of 21st of October, and we shall continue the study of 2x2 system modeled by biophysical examples, biomedical examples. Okay, first of all, students here and in internet, I am waiting your questions or something unclear from the last lecture. We started to study this 2x2 system in general. I start to write from here above. Can you see from here above? Yes, okay. Here, more or less. For you, but for her, let us be. Here is okay? Okay. Therefore, our system was x prime equal f x epsilon, and epsilon prime was g of x epsilon. And after this, we shall put some initial data. Last time we tried to apply Taylor formula to linearize and simplify our system. Before making another example of this Taylor expansion, I want to clarify how we shall present the solution, because we want to understand from graphics what is the behavior of our solution. So usually to present our solution, we take some reference, which means we have a coordinate system that is has two axes, the x and the x epsilon. If, for example, we take a point that has coordinates x0, epsilon 0, this point P0 with coordinates x0, epsilon 0, may be our starting point. So, therefore, this point will correspond to the choice of our initial data. So here we can take, for example, x in the moment 0 equal x0, and epsilon in the point 0 equal epsilon 0. We shall call this choice initial data. So we have initial data. Why initial? Because t is equal 0. And our initial point is our point P0 on our reference in the coordinate system. So what is the purpose? Our purpose is to build, for example, in the point T, the point with coordinates xt and epsilon t. So this point, as you can see here, is xt. This here is epsilon t. It is clear that P0 is a fixed point, is not moving, while Pt, when t varies, this point Pt is moving. Therefore, in general, when the point Pt is moving, we have kind of a curve. And we can say when t is moving from 0 to t, our solution xt will produce kind of a graphic. So we have a curve. How this curve is defined? X is xt. We define this curve with the following system. X is xt and epsilon is epsilon t. And it is clear when t varies, for example, from 0 to some, let's say, capital T, When the time is in this interval, then we have curve defined by this equation. And this curve, practically, we have to present on the coordinate system. And this curve will represent geometrically our solution. So let us take one example, one simple example to build such curve, to understand how we shall transform our solution that we shall find explicitly into such curve. Okay, let us take one example. In order to take this example, I shall shift the blackboard, half of the blackboard up, in order to be seen by students in class. And if you finish to write it, let me, yes?
The capital T stands for?
This stands simply for a time interval where we study our process. For example, if we know that this model is for human being, it shall be 200 years, for example. Something that is given for our model. Thank you for your question, please. Yes, I am planning to put... Alzare il lenzuolo bianco. Eccolo lenzuolo. Mica usate questo lenzuolo nel letto. Oh, duro, ma se mi dite che si usa quello, va bene. Ok, allora, therefore, turn to the English. Now we are looking for some appropriate words. Yes, let us... So we are here, and we shall produce here an example. I use this part of the blackboard so students can see, and also you can see. Unfortunately, cannot use the part below. So let us take x prime equal, for example, minus x, and epsilon prime of t is epsilon t. So as you can see, our function f and g, they are very simple, linear. You can think after Taylor expansion, we have this system, and we take x0 equal, let us take x equal 1, and epsilon 0 equal again 1. So our initial point is the point with coordinates 1, 1. Now, what we have to do? First of all, in order to know our picture, we shall try to solve this equation, because this is very simple equation. We know the solution of this equation. The first equation can be solved explicitly, so we have xt shall be equal our initial data 1. Since here we have sign minus, we have a to the power minus t because of this sign minus. Therefore, exact solution is a to the power minus t. At the beginning of our course, we deal with such equation. They are with separated variables. So I skip the solution. I am writing you directly the solution. You can check that this function, when you differentiate, you get x with sign minus. This is obvious because a to the power minus t after derivative gives you in front sign minus. Therefore, you have this solves this, and when you take t equals 0, this is satisfied. Therefore, this is the solution. And again, we can solve epsilon t. You can help me now. What is epsilon t according to you? This shall be 1 multiplied by a to the power t. So epsilon, when t grows, epsilon is growing, x is decreasing. Okay, let us try to build our picture, at least for t close to 0. Let us try to see what will happen when t is between 0 and 1. we have chosen capital T equal 1 because this is, as I said, we want something not very big. And let us try to build our curve. One simple way to build the curve is simply to exclude t, to obtain equation for x and epsilon. In fact, if I call epsilon a to the power t, what shall be x? This a to the power minus t, this is 1 over a to the power t. Because this is the definition, a to the power minus. Therefore, from this, we can get very simple equation for our curve. We have x equal 1 over epsilon. This practically, as we said, we exclude the parameter t and obtain one equation, x equal 1 over epsilon. It is clear that this can be written also as x epsilon equal 1. And now we can, I don't know, probably the simplest solution is take x epsilon, and we can interpret our curve as graphic of the function epsilon as function of x, because usually you build a graphic knowing your function epsilon. How we shall express epsilon in terms of x? Epsilon shall be 1 over x. This is from this. So from here, we get epsilon equal 1 over x. This is elementary function, and we can build very easy the graphic. How we shall build? Putting few points to have the idea how is the graphic, and then connecting these points. For example, when we have 1, 1, we said this is our initial point. This is one point of the graphic. So this is 1, and this is 1. If I take x2, what shall be epsilon? 1/2. Therefore, shall be much smaller, half of this. And you see, I get this. This is 1/2. This is 2. If I take, for example, 4x, what shall be epsilon? X is 4, 1 over 4. So even smaller, half, 1 over 4. And as you can see, connecting, sorry, my pictures are bad. You see, this is function decreasing, but when x goes to infinity, 1 over x goes to 0. Therefore, we have such behavior. And of course, here you can see, for example, if I take 1/2 for x, what is epsilon? If x is 1/2, epsilon shall be 2. Therefore, if I take smaller, this will grow. And as you can see, we have usual elementary function that is epsilon equal 1 over x. This is our curve. And when you know the equation connecting epsilon and x, you can build and say, if I start from 1, 1, let us see the following thing. In order to show how the time is growing, I shall put kind of a row. So this is my initial point, and I am asking where we go, here or here when t grows, because we start with t equals 0, and then when the time increases, in which direction I shall go, because this is very important information on our representation of the solution, to build the arrow showing where the time is growing. Let's see here in the equation. If t grows, X is increasing or decreasing? X is decreasing. So the correct direction of positive time is where X is decreasing. Therefore, this or this, obviously, this is the correct arrow, because here X is decreasing while epsilon is increasing. So this is a wrong arrow. And in order to show how the time is growing, we say, okay, we put these arrows showing what will happen when the time starts from 0 to plus infinity. And this means when we have t from 0 to 1, we have only part of this curve. And this is the correct arrow we have to put. So as you can see, the information for our solution contains two important points: graphic, and then the arrow that shows where we are going. Because it is important to know if this is the point of health state. This means where in our model, all cells are stable, and this is kind of health state. So no disease. It is important to know where we go, in this direction or in the opposite direction, because in one direction, X is decreasing, in the other direction, X is increasing. If X is, for example, cancer cells, this is very good if we move in this direction, while if we move in the opposite direction, the number of cells, bad cells, increases. Therefore, we have graphic and also arrows. Let me stop for the moment and ask you for your eventual questions. I want to ask students following by internet if they see well, and if also the voice, because my microphone is not perfect. Do you hear well? Do you understand? And if you have some questions. Please. Prego, se ci sono...
For understand where the time goes, how I can understand where the time, when X decrease, is the direction of time.
Depends on our solution. This shall be determined by our solution. If we want to understand better the arrows, we look at the solution. And usually, if you have explicit function, in this case, decreasing function, this means t grows, X decreases.
Perfect.
This is very significant, and you shall see, you shall have more experience with different models, and you shall see that you shall have this capacity to understand the arrows. But it is crucial to know explicit solution. That's why we simplified essentially our system, and then we can solve explicitly.
On the graph, where is represented?
Sorry?
On the graph.
Yes?
Where is represented?
T. This is a really hidden variable, because the time, formally, we can put another x. So we shall have 3 x's. But instead of having the time as x, we project on xy plane, and then we interpret our third direction as particle that is moving. So this point, for example, starting from here, start to move. You know, when you have a particle, then the trajectory of the particle is kind of curve, can be also line, but in some sense, this is a curve. And therefore, the time is the parameter of the curve. As we have written here, and as we have written here, this is the equation of the curve. The curve has parameter. This parameter explains our points when t is moving, where they are moving. And therefore, we have, in this case, the curve is associated with this parameter. And since we build the curve, the parameter practically describes how our particle is moving on the curve. So this is more or less the explanation. Otherwise, again, we can build, let's say, the time up. But when you have system 3 by 3, can you imagine 4-dimensional space? We are living in 3D. Therefore, it's a little bit complicated. That's why the dimension is somehow hidden. The third dimension we interpret as time connected with the movement of this particle that is described by this equation, by this system. Always the curve is defined x and y by two functions depending on parameter. And this parameter of the curve typically is associated with the time. Okay, this is a little bit small psychological problem to understand that the time is not formally represented, but we can see how the behavior of our solution is described looking at the curve and especially using the arrows. The arrows, they show how time is moving. Another interpretation to answer to your question is to say, formally, I can associate this is t equals 0. But if I take this point, let's say pt, then you can ask where is the time? And the answer geometrically is very simple. Roughly speaking, this is the length of this arc. If you measure the length of this arc, this is your time. So this is geometrical interpretation, but I didn't want to go to this little bit more sophisticated mathematical or geometrical notions. Somehow we shall see that in many cases we can also measure the time explicitly by using the equations. And this we already did. Using the equation, we know t is growing, x is decreasing. If we have explicit solution, and typically for linear systems, we shall have similar solutions. Okay. Other questions? So this was very important point. One moment, there is in chat. Okay, in chat, okay, you can hear, you can see, this is very good. Now, let us go further with another question connected with another example, because this was our example 1. Now, let us go to example 2. Yes, this is the best way to clean. Okay. Now, the next example, there is something to, yeah, I have to take the next time. Probably this should, because this is a little bit wet and is not bad. It's bad to write on wet whiteboard. Okay, this is working. So, again, this is our generic part, and now we go to the next example. The only thing, our next example contains something that may happen in our example 2. X prime is x minus epsilon, and epsilon prime is epsilon. This was very easy in the previous example, to have one equation only with x and one equation only with epsilon. Now we have equation where x and epsilon, they interact, still linear equation, but we are asking how to solve this equation, because we promised that in general we may take our x epsilon t and consider this couple x epsilon as a vector, because we know that any two x epsilon on our reference, on our coordinate system, they represent a point. So let us call this vector ut. Of course, this vector has two components, and it is quite simple to rewrite our system 1 as a simple equation u prime of t equal a of u. What is a? Since u is a vector, a shall be a matrix, 2 by 2 matrix. So we have to apply our matrix. Let us see this matrix. Let us suppose A is A11, A12. Here you can see probably, yes, A21, A22. Prego. See?
After the A,
yes.
What is
I am representing our matrix.
No.
This is the matrix A applied to you.
Okay.
Now I shall explain what does it mean. The matrix A, if I apply to you, this means I have to take my 2 by 2 matrix A11, A12, A21, A22, and apply to my vector that is x epsilon. And as you can see, when we have generic matrix of this type, what we have to do? This line by this column, remember that we had a part devoted to 2 by 2 matrices. So now we connect different pieces of our math tools in order to see how simply we can solve this equation. So this is first time A11x plus A12 epsilon. This is our first component. The second component is A21x plus A22 epsilon. And you see, instead of writing a complicated system, in this case, our system will be x prime shall be, I am looking on the derivative. Derivative of u, this means derivative of this and derivative of this. And I am writing the first component. This is x prime shall be equal to first components. Therefore, shall be A11x plus A12 epsilon. And similarly, epsilon prime shall be A21x plus A22 epsilon. What we have done? Actually, you can compare this system. I am sorry, probably students cannot see. Now they can see. This system and this. Let us call this 1 and this 2. I am asserting that when you have such system with two lines, you can rewrite, this is the same system one, but you rewrite as vector matrix. You rewrite it as vector, derivative of a vector is a matrix applied to U, to the vector U. This and this is the same due to this calculation that we did on the blackboard. This line that we represented, we saw that A of U is a vector with two components. U prime, if I put U prime, I have to take here the prime. Therefore, now, if I look here, look the first line. What is the first line? X prime on the left. What is the first line on the right? This is this guy. And I take X prime equal to this. It is written here. Similarly, the second line. The second line is our second line. And you see, you can write the system in very, how to say, detailed form, but you can rewrite your system too in very simple form, simply defining your matrix A. And now, I shall try to apply the same thing to find my matrix A for this system. Now I mentioned something bad on the blackboard. I used 1 and 1 2 times. Therefore, let us put 1 prime for this guy, because this is for example, while 1 and 2 are for generic matrix form. Okay, now I want to see how I can transform my example 2 into very compact system, and how we can define our matrix A. So I shall shift the blackboard if you finish, and shall use this part. Prego, please.
We compute the matrix applied to U and U prime.
Yes.
And then we write in a system by putting X prime and Y prime, which is U prime.
Yes.
Equal to A apply U that I have.
Yes, yes. So we have vector equal vector. And what we have written here is components of our vectors. Okay. This is by components written in this way. Okay, now we start. What we have, what we want to do. You can see we have in our example X prime, Y prime is X minus Y, this is Y. What is our purpose? As you said, here we have on the left a vector, on the right we have a vector. So what is our vector on the right? Our vector is first component X minus Y, second is Y. What we are looking? We are looking for a matrix. Let's put this matrix A11, A12, A21, A22, so that applying to XY, we have identity. We have to choose A11, A12, all components of the matrix A. And you can easily see, if the rule is this multiplied by this vector. On the first line, I simply shall use the coefficients in front of x and epsilon. So I put here equal 1. This is coefficient in front of x. And the second one is minus 1. Minus 1. Why? Because this is coefficient in front of epsilon. We are looking at the second line. Second line, how is obtained? This line multiplied by this column. But in this product, we have to see, first of all, where is x? There is no x. Therefore, coefficient in front of x is 0, if there is no x. So I put here 0 in order to disappear x. And A22 coefficient in front of epsilon, which is 1. And you can check now very easy that 1 minus 1, 0, 1, x epsilon. This is exactly what you are looking for. And in this way, we can say our system 1 prime can be rewritten as u prime equal a u, where A, you can help me, what is A? The matrix that we found. So this is 1, minus 1, 0, 1. This is more or less the way of approaching all possible linear equations when we have x and epsilon as linear combinations. This is very important because with this reduction, we can, after this, apply very simple rules. We are not, at the moment, very ready, but it is important to connect with this example our 2x2 system with the matrices that we studied at some point in the details. Okay, let us now solve our equation. Of course, it is very simple to solve the second equation. Why? This is equation all in epsilon. Now we are going to our example and we solve the equation for epsilon. Epsilon prime equal epsilon. Let us put here initial data again. 1, 1, the same initial data. I add here x0 is equal epsilon 0 equal 1 for simplicity, as in the previous example. So we add this initial data, and now we are ready to solve only the second equation with initial data epsilon 0 equal 1. This problem we studied at the beginning of our course, and we have explicit solution. Epsilon t is a to the power t. And that's all. This is the exact solution. Let me recall you once time. If you have, remember, epsilon prime of t equal constant epsilon t with epsilon 0 equal epsilon 0, the exact solution of this Cauchy problem can be written. I need a small part here, so I shall write the solution here. Is epsilon t is our initial data epsilon 0 a to the power c t. This is the solution explicitly. When c is positive, as in our case c was 1, we have growth of this function. When c is negative, we have decreasement of this function. And as in the previous example, we had ones minus, ones plus, but in general, we have this solution. Therefore, this shall be quite useful. and we shall return back to this solution. So epsilon is found, and we know that in our case, epsilon 0 is 1, so I applied this formula and obtained this solution. And what we can do, take epsilon, plug in the first equation, and we already had a formula for solution of the first equation. This was actually some lectures ago. We studied such linear equations. The only thing I need a little bit space. That's why, for the moment, we shall turn to our blackboard, and I am planning to shift above in order to use the part. And that's why let me ask you if you already copied the upper part of the blackboard, so I can shift a little bit. And what shall do? I shall plug in this first equation, I shall plug my solution obtained already, my epsilon. So after a while, we shall finish this example, and we shall make a small interruption in order to save our first movie and have small coffee break. Okay. Let us now turn. As we explained, epsilon is known, so we have this solution. X prime is equal to x minus a to the power t. This equation is partial case of very general equation that we studied. This was epsilon prime, x prime of t equal at xt plus bt. This type of equation in our previous lectures we treated, and you see this is partial case of this equation. It is not necessary now, I understand very well that any new appointment with math tools is not very easy, but the important thing is to remind you that this already there is algorithm for this solution. So how we can solve? The solution is very simple. We put, we make first forget about b, and then we solve formally x prime equal x. This equation we know to solve. The solution x shall be chi a to the power t. So what we are doing, we say, that's why this method is called method of varying the constants. So this solution is okay when there is no bt, there is no such term. If we want to solve with bt, then we shall assume that c is not a constant. Therefore, let us put here ct. This now, xt equal ct a to the power t is not solution, but this is simply substitution, because substituting x in our equation, we shall get new equation for c, and this equation is much simpler. We can find and solve it very easy. Let us plug. Compute the first derivative. What is the first derivative of x prime? I explain again, repeat, because once is not sufficient. Now repeat, method of varying of constants. X prime, derivative can be all or on c or on the exponent. So we apply the formula, derivative of product of two functions. This was a formula explaining that the derivative is first derivative multiplied by this function plus this function by derivative of this function. Therefore, we have c prime of t, a to the power t, plus ct is left, and we have to take derivative of a to the power t. A to the power t has the same derivative, is the same, a to the power t. Perfect, we are ready. So, let us take now x prime, x, and substitute in our equation. What will happen? In the left, we have these two guys. So we can write c prime of t, a to the power t, plus ct, a to the t, is equal. This is the left-hand side, x prime. On the right-hand side, we have x, but what was x? Ct, a to the power t. And then what is missing? Only this guy, minus a to the power t. And you shall see now how beautiful we can find really magic cancellation. What is this magic cancellation? I'm sorry, I have no red one because the black color is seen better, but you see, cancel this and this, and we have another nice cancellation, a to the power t. A to the power t on the left, on the right, can be cancelled, and we get, as I promised, very simple equation, c prime of t equal minus 1. This is one simple equation. What is saying this equation? This is saying that our function c is primitive of minus 1. When you integrate minus 1, what is your primitive of minus 1? This should be minus t, because minus t has derivative minus 1. So from this, I shall shift a little bit in order to show. This becomes real movie with a moving camera. And now we have ct is minus t. And this is the moment where I have to remind typical error of the students, forget plus constant. When you take primitive, always, this is minus t plus some constant. Plus, let us go, since letter C is reserved for our function, let us invent another letter, for example, D. D is a constant. You can see the constant, and now we have our solution. Ct is found. I shall plug inside x, and in this way we shall have finally our solution xt. So xt, let us write, as we promised, this shall be minus t plus d multiplied by a to the power t. And this is our solution. What we don't know is what is d. From where we shall find our d? Of course, from initial data. We know x in 0. This was, let us remind you, for students here above. As you can see here, we have taken initial data in the point 1, 1. This means in this relation, I know that x0 is 1. So if I take t equals 0, I can compute x0. This shall be with t0 remains d. When t is 0, a to the power 0 is 1. So when t is 0, I get d on the left, on the right, 1. And we are ready from our initial data to say finally what is the solution. Xt we can write here the official answer. Xt is 1 minus t a to the power t, while epsilon t is a to the power t. And we have to build now the curve. But since I promised coffee break, it is 2 minutes before the coffee break, I am leaving to you during the coffee break to a little bit relax. And after the coffee break, we shall try to build our curve, which is already algebraically, explicitly obtained. What is the difference between the previous case and the new one? Here we have kind of linear function in t. Therefore, for example, when t is 0, you see this is 1, this is 1. But when t starts to be bigger, for example, t equal 1, what will happen with this guy? 0. Therefore, we shall have a little bit curve that is different from the curve that we built, for example, 1. But once you have explicit formulas, then it's easy to build our curve. Okay, let us make now the break, and we shall continue after approximately 5-10 minutes with very short movie for the second part. And we shall start with your questions. I shall stop now the registration, the movie, and shall switch off for 5 minutes.